Okay, so we've got a tiny grain of pepper. That's a different rock from basalt, right? We know of basalt, but pepper is. See, I can't tell if you're laughing. I don't hear any laughter. Okay, so let's draw a picture of this guy. Here he is. He's falling down through this water, right? Which has this this viscosity, right? And the water has this density. Notice that the rock has this density, the pepper, right, as it were. Now, the forces acting on this are, of course, we've got gravity acting down, so mg. We've got a buoyant force acting up, and then we've got, of course, the drag, the Stokes force. Do they call it? Is that drag? I don't even. Why is that D? I don't know. I should know. I'm your teacher, right? So these, if this thing is moving at a constant speed, then and it will, okay, then all these forces must add up, okay. So I think what we're going to do is we're going to figure out the B. We're going to find out mg, and then knowing that, we'll know how big this drag force is, right? And then we can figure out the velocity. Okay, so we're going to use force of gravity is mg, and the density is mass over volume, right? I'll do my volumes with little ears on them there, right? We're also going to use buoyant force is the density of the fluid times the volume of the fluid displaced times gravity, right? And then we're going to use the $6 million equation that the drag force is, or the Stokes force is 6 pi times the viscosity times the radius times the velocity. This is not a volume, this is the velocity, the speed with which it moves down, right? Okay, where do we start? Let's find B first. Okay. Okay. So B is going to, hey, Mr. Duggan. B is going to be the density of the water, right? 1,000 times, let's see, the volume of this thing. Oh, dear Lord. Okay, so it's going to be 4/3 pi times, it's 1.2 microns in diameter, so it's 0.6 times 10 to the minus 6th to the third, right? Okay, and then times 9.81. Okay. So let's figure this out. So the buoyant force is times 4 divided by 3 times pi times 0.6 e minus 6 raised to the third power times 9.81. Okay. It's 0. Wait. How about scientific notation? Okay. Answer. It's 0 to the 0. Okay, well, what did I do here? Okay. That's kind of funny. Times 4 divided by 3 times pi. Let's try this again. Times 0.6 raised. Oops. Oh no. 1,000 times 4 divided by 3 times pi. It's small. I knew it was small, but maybe it really is 0, right? Pi times 0.6 e minus 6 raised to the third power. Oh, here we go. Times 9.81. I know what I did. I know exactly what I did. Okay. Okay. It's 8.8758 times 10 to the minus 15th newtons. Holy cow, who cares about forces this small? Okay, so now let's find the force of gravity, right? So mg is going to be, it's going to look really similar, right? It's going to be 1,000. Oh wait, no, not 1,000. 2130. All right, so I'm just doing this. Force is going to be density times volume times g, right? Which looks a whole lot like the buoyancy thing because that's where it comes from, right? So that times 4/3 pi times 0.6 times 10 to the minus 6th to the third, right, times 9.81. Oh, I need a parenthesis in there. There we go. 9.81. Okay, so let's figure this out. Okay. I'm actually going to take the number that I just typed in. Everything's going to be the same except for that density, right? So I end up with 2130. Okay, here we go. And this is, it's somewhat more, right? It's 1.89056 times 10 to the minus 14th newtons. Okay. Okay, so the Stokes force has to equal, I guess, the difference between the gravity and the buoyant force, right? Okay. If you want to see, let's do this all formal, right? So we can say B plus the Stokes force plus the force of gravity is going to add to 0, right? Because it does move, but it moves at a constant velocity, right? So this is an upward force. Gravity is going to be a downward force, so we end up with minus 1.89056 times 10 to the minus 14th plus 8.8758 times 10 to the minus 15th plus the Stokes force is 0. Okay, so ultimately I'm going to end up subtracting these numbers. So this guy minus this guy. So the Stokes force is 1.00297 times 10 to the minus 14th newtons, right? And now we're set. Now we're almost there, right? So I can set that equal to this. So that equals 6 times pi times, what's my viscosity? 1.002 times 10 to the minus third, whoops. And that's Pascal seconds. Okay, times V, the variable. Ooh, we are almost there. Okay, so I'm going to take this number that's on my calculator, divide by 6, divide by pi, divide by 1.002, e minus 3, and I'll get V. God, I hope this is right. Okay. Oh, no. Oh, dear. Let's see. Oh, R. I forgot the R. Okay. R. Okay, the R is 0.6 times 10 to the minus 6th meters. Okay, I forgot the R, right? There's an R in there. Okay, I forgot the R. This is like the worst video ever. Okay, so I need to divide that by 0.6 E minus 6. Yeah. Okay, so my V is equal to 8.85 times 10 to the minus 7th meters per second, right? Now, obviously, you can figure out the buoyant force. You can find the weight. The difference in between the weight and the buoyant force is this force here, right? We can streamline this a little bit, right? Because the difference between the B minus mg, right? This is just rho of the fluid, volume of the fluid, times gravity, minus rho of the object, volume of the object, right, times g. Well, the volume of the fluid displaced and the volume of the object are the same, right? So the net force, which is going to become the Stokes force here, right, is going to be volume of the object, right, times g, times the difference in those densities, right? So density of the object minus the density of the fluid, right? So you can save a lot of steps here, right? You can go 4/3 pi times 0.6 times 10 to the minus 6th to the third, right, times 9.81 times 2130 minus 1,000. And that'll give you, you can arrive directly at your what the Stokes force is. So 4 divided by 3 times pi times 0.6 e minus 6 raised to the third times 9.81 times parentheses 2130 minus 1,000. And there we go. We end up with 1.00297 times 10 to the minus 14th. And then you can just use the Stokes equation, 1.00297 times 10 to the minus 14th is equal to 6 pi times r times v. Don't forget the r. 6 times pi times 1.002 times 10 to the minus third times the radius 0.6 e minus 6, right, times v. So again, if you just divide by this, by this, by this, by this, you'll end up with the same velocity. This is like, hopefully you didn't listen all the way to the end. Maybe you did. I think my best stuff was at the end there.